two projects. In this video, we are going to explain about the project that is tree-based ensemble algorithms and feature selection method for intelligent distributed denial of service attack detection. So before getting into the execution, first let us understand what is this project about. So basically in today's world, almost everything relies on the internet. That may be businesses, banks, government services, even entertainment platforms rely on internet. Because of that, cyber attacks have become a big threat. One of the most serious types is called distributed denial of service or DDoS attack. So what happens with this DDoS attacks is that the attacker floods a website or a server with an enormous amount of traffic, like hundreds of thousands or even millions of requests all at once. The system can't handle so much traffic at the same time, so it either slows down or dramatically or it stops working completely. This doesn't just cause inconvenience, it can shut down services for businesses, prevent people from accessing important websites, and even cause financial losses. Some big examples are attacks on Amazon Web Services, GitHub, and cryptocurrency platforms. These attacks were massive and they show just how powerful and disruptive these DDoS attacks can be. So, here, the main problem with DDoS attacks is that they need to be detected fast and accurately. Traditional ways of detecting them, like simple traffic monitoring or fixed rules, often fail because they can't tell the difference between normal user traffic and attack traffic, especially when attackers change their methods. So, because of this, there is real need for smarter detection systems, that is, smarter detection methods that can adapt to changing attack patterns and keep important online services running smoothly without getting disrupted. So, to overcome with all such issues, this project that we have developed is aiming to catch DDoS attacks early and more effectively. So, instead of relying on old fashioned methods that often confuse a normal traffic with attack traffic, this system uses ensemble learning, which basically means it combines multiple machine learning models to make better decisions. On top of that, here we are using Gini index. So this Gini index, it picks out the most important features from the data so the system can focus on what really matters. This makes detection not only more accurate but also faster and more efficient. So it can handle big amount of network data without slowing down. And to make the system work, here we are using UNSW NB dataset, which has examples of both the normal network traffic and also different types of attacks. But instead of looking at every single piece of data, we used enhanced Gini index to pick out the 13 most important features. This means the system only focuses on the data that really matters, which makes it faster and more efficient at detecting attacks without getting bogged down by unnecessary information. Once we pick out the most important features, we train and test on three advanced machine learning models that is three advanced ensemble machine learning models that are random forest, XGBoost, and AdaBoost. And these models are evaluated using accuracy, precision, recall, and F1 score. So they are evaluated using this scores. So this means our system not only strong and reliable but also efficient and scalable. So it can handle large amount of network traffic data while keeping the system secure and minimizing the use of resources. And to further improve the performance of this project, several enhancements are added. So here in this project, first, we have enhanced how we select important data features by using mutual information and balancing the data set using smoothing technique, which helps the system to learn better from all the type of traffic. And then we have incorporated voting classifier, which is an other ensemble model. So this combines multiple machine learning models to make predictions more reliable. And here, to make the system decisions easier to understand, here we are using explainable AI tools that are live and sharp, which show why the model made certain predictions and which features were the most important for that. Finally, we created a web-based interface by using Flash. So users can either log in, that is, user can either they can enter the data and get predictions. And this interface also includes user authentication to make sure that only authorized users can access the system, keeping it secure and trustworthy. So with this, users they can directly interact with the web application and they can get the predictions without running the complete code. Moving on, to implement this project, Here we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented the project. First, we have imported all the necessary Python libraries for data processing, machine learning, evaluation, and web development. Then comes data ingestion. So at this step, we load UNSW NB15 dataset into Pandas data frame. So this dataset contains both the normal and attack network traffic, which will be used to train and test the system. After loading the data, we do pre-processing. So at this stage, we clean the data by handling any missing values, either dropping them or filling them. Categorical variables are converted into numerical form using label encoding, and all the numerical features are standardized to ensure they are on the same scale. And if the data set is imbalanced, we use smooth and smoothing technique to balance the classes so the model can learn equally well from all types of traffic. Then comes feature selection part. So here we are using two types of feature selection technique, that is Gini index and mutual information, that is the extension technique. So the system picks out the most important attributes using Gini index, and as an extension, mutual information is also used to further reduce the number of features, focusing on what really matters for detection. Then comes data splitting. So at this stage, we split the data into train and test sets, where training set is used to train the model and testing set is used to evaluate the model. Then comes model building and training. So at this stage, we train multiple machine learning models, including random forest, XGBoost, AdaBoost, and Ensemble voting classifier as an extension version using the selected features. And we will be evaluating all of them using accuracy, precision, recall, and FN score. And a confusion matrix is analyzed to check the false positives and false negatives. Then comes applying XAI techniques like using Lyman Sharp. They are applied to understand which features contributed most to the predictions. And we will be saving the best performing model for the future use, that is for doing prediction in the front end. And coming to the part of Flask framework, that is Flask web application, here we have used Flask framework to develop a simple user interface, that is web application using Flask. So it's a simple form. It's a created where users can input feature values for the prediction, and users are authenticated to ensure secure access, and the saved model and scalar are loaded. Incoming data is pre-processed and fed into the model. The system predicts whether the input corresponds to normal traffic or an attack. Then the results are displayed to the user via the web interface. So this is how we have implemented the project. Now moving on to the algorithms used. These are different algorithms used. So we have used XGBoost, random forest, AdaBoost, multi-layer perceptron. We have used decision tree and extension voting classifier. So these are the algorithms used. And to implement this project, basically we need two kinds of requirements, that are hardware and software. So in hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, and database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, open the code folder that contains source code files. So these are the source code files of the project. Let's understand them. In this folder, we have dataset that we have used in this project. And here we have model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder in which we have CSS, JavaScript, and Bootstrap files, which are important for the project's visual appeal. And this is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases in which we have sample files that we will be using in the front end. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Here we have notebook file. It's a Jupyter notebook file, and it contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And we have signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open Anaconda prompt. It is open. Give the command cd, give the space, paste the copied path, and click on enter. Here, if you observe, current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port. So this 5000 is the port and this is the localhost. And now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Chrome, that is Google Chrome, so I will paste it in that. Paste the link here and now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So this is the web page of this project. So click on try detection. For that, you need to create an account and fill in all these details. I have already created account, so I'll directly sign in. Click on sign in and give username and the password. Click on login. You can log in this way, or let's log out and see another way. So directly you can click on sign up and give sign in. Click on sign in, give username and the password. We have signed in successfully and redirected to prediction page of the project. And here you can see multiple parameters, right? So these are the parameters need to be given as input for predicting the attacks. So first parameter we have is the protocol. It is the type of network protocol used in the connection like TCP or UDP. It tells us the system, that is, it tells the system how the data is being sent. Then we have source bytes. So here we have source bytes. These are the total amount of data in bytes sent from source device during the connection. Then we have destination bytes. These are the total amount of data in bytes received by the destination device during the connection. Then we have service. It is a type of service or application involved in the connection like HTTP, FTP, or DNS. Then we have source load. It is the amount of network traffic or request being generated by source device. Then we have source mean size. This is the average size of packets sent from source, that is sent from the source device. Then we have connection count service source. So this is the number of connections made by the source device to a particular device. Then we have connection count service destination. This is the number of connections received by the destination device for a particular service. Then we have connection count destination last time. This is the number of connections the destination received in the most recent time interval. Then we have connection count source last time. So this is the number of connections the source sent in the most recent time interval. Then we have connection count source destination port last time. This is the number of connections from the source to the destination on a specific port during the last time interval. Then this is the connection count destination source port last time. It is the number of connections from the destination to the source on a specific port during the last time interval. The last value we have is connection count destination source last time. This is the total number of connections from the destination to the source in the most recent arrival time. So let's start entering them. For that, let's open test cases. Open test cases. It's opening, just wait for a while. And here it is open. Here is the target column that we will be predicting. So let's apply filter to it. And here we have total 9 different targets. So let's apply filter to class 0 and click on OK. Click on OK. And let's start entering them. So here protocol is 109. So enter it. And here we have S bytes. So source bytes are 786 and destination bytes are 662. Service is 1. And then we have S load. Let's copy it and paste it because we have decimal points there. And then we have source mean size, that is 56. Connection count service source is 1 and the all other values are 1. So let's enter all the other values as 1. Now click on analyze network traffic. So here we got the prediction. So here we have analysis summary that it is predicting analysis attack with the confidence of 70.43% confidence score and the risk level is low. And here you can see analysis details. So this is the processing time. Here we have algorithm used, and here we have features analyzed that are 13 features. And here we have detection summary. So this is the detection summary. Now let's check with the other one. So click on analyze another sample. Let's check with class 1 now. Apply filter to it. Click on OK. And let's start entering them. So protocol is 115 and source bytes are 168. Decision destination bytes are 0, service is 0, and then source load is 74666. We have some change. And then we have S means, that is source means 84. Connection count service, that is 1. Connection count service destination, it is 2. Connection count destination last time 1, and other last values are 1. So let's enter all the other values as 1. Now click on analyze network traffic. So here you can see backdoor attack has been predicted with the confidence of 96%. And here we have risk level, which is very high. And here we have analysis details, detection summary, and here we have threat analysis. It is a backdoor attack and threat level critical system compromise detected. Here we have description about the backdoor attack. And here we have immediate actions required. So what are the immediate actions to be taken when a system has this backdoor attack? And here we have security recommendations, next steps. So you can do monitoring and detection, prevent measures. Here we have team and training. Now let's try with the other sample. So let's apply filter to class 2. Click on OK. And let's check with this case. So protocol is 109. Source bytes are 737. Destination bytes are 339. And then 0, service is 0. Then we have S load, that is 11,972. And we have the other values, that is S means, that is 73. Connection count 1. And the all other values are 1. Let's enter them. Now click on analyze network traffic. Here, if you observe, DOS attack has been predicted with the 95% confidence, that is high risk. And here we have analysis details, detection summary, and here we have threat analysis and information. So here we have denial of service attack, threat level is high, and immediate action is required. And here we have information about DDoS attack and immediate what are the immediate actions to be taken next. And here we have the other recommendations. Let's try with the other sample. Let's apply filter to class 3. Click on OK and check with this part. That is this case where protocol is 109, S bytes are 870, destination bytes are 1211, and service is 5. Source load we have 4879, and then S means is 86, and then connection count service it is 3, 2, 2, 1, and then we have 16, 1, 1, 2. Now let's click on analyze network traffic. And here you can see detection result, that is exploits, and confidence is of 98% and risk level is very high. And here we have analysis details, detection summary, and here we have threat analysis. So here we have threat level high and vulnerability exploitation. Here we have description. This is the description. And here we have immediate actions required. Now let's try with the other samples. So let's apply filter to class 4. Click on OK. So here we have protocol, that is 104. Source bytes are 360. Destination bytes are 0. Service is 0. And then S load is 2135. Let's apply filter to it. And then we have S means it is 90. And then all other values we have as 1. So here connection count service is 1. Connection count service destination is 1. Last time is also 1. And then we have 2 and all other values are 1. Click on analyze network traffic. Here we have detection result as fuzzers with the confidence of 74.94%, and the risk level is medium. It is not high, it is not low, but risk is there, that is of medium level. And here detection summary, here we have threat analysis where threat level is medium, and here we have other things also. Let's try with the other sample. So let's try with class 5. Apply filter. And let's check with this case where protocol is 109, source bytes are 533, and 354 is destination bytes, services 4, and S load is 9279 point decimal points we have. And then we have S means that is 50. Connection count is 1, 1, and we have all other values as 1. So let's enter them as 1. Now click on Analyze. And here you can see generic attack has been predicted with the confidence of 58% and it is of medium risk. And here we have analysis details. And here we have detection summary also, threat analysis. Let's check with the 4 more cases. So here we have, sorry, we have only 3 more cases. Let's apply filter to class 6. Let's check with this one. So protocol is 109, 785, 3008, 5, and then 6088 point change we have, and then 78, 2, 1, 2, 1, and the all other values are 1. Now click on Analyze Network Traffic. And here you can see reconnaissance attack has been predicted with a medium risk of 78.83 confidence. Let's check with 2 more cases. So click on Analyze Another Sample. So let's apply filter to class 7 and click on OK. Let's check with this case, or else let's check with this case. So protocol is 115, 114, 0, 2, and we have 152 and some zeros, that is source load. And then S means is 57, 57, connection count is 17, 17, and we have 17. Here we have 17, we have total. All the other values are 17. So let's enter them as 17. Now click on Analyze Network Traffic. And here you can see shellcode attack has been detected. If you observe, we have shellcode attack with the 100% confidence and we have medium risk. So shellcode is of medium risk. The application, I mean, the system where this network flows has been affected with the shellcode with the medium risk. And here you can see all the other information. Let's check with the last sample. So let's apply filter to class 8. Click on OK and check with this case where proto is 109, source bytes are 5180, that is 5800, 5180. Destination bytes are 9000, sorry, 91,000. And then we have service. And here we have S load. S load is 4755. And S means is 45. Connection count service and all the other values are 1. So let's enter them. Now click on Analyze. So here you can see worms have been predicted. So here if you observe, worms have been predicted. And here we have analysis result, confidence score, which is of medium risk, worms are of medium risk. And here we have analysis details, detection summary, and here we have threat analysis. So it is about worm attack. And immediate attacks, that is immediate actions that are to be taken. Now let's check with the graph. So click on graph. And here we have multiple graphs. So here we have sample outcome graph. Here on x-axis we have all the types of attacks and on y-axis we have count of each attack. So this shows the class distribution of each class that we are having in this project. And here we have class distribution before and after mode. So here you can see only generic cases are more than the other classes. So after applying mode, here we have the balanced data set. So you can see the distribution which is balanced. Close this. And here we have confusion matrix. So this is the confusion matrix and here we have ROC, AUC curve graph. Close it. Here we have accuracy comparison graph. So here on x-axis we have all the models that we have trained and on y-axis we have accuracy. Close it. Here we have precision score. Here we have recall score. And we have FN score. And last we have is the XAI SHAP analysis. So here on x-axis we have SHAP value and on y-axis we have all the features. Now close this. Now click on sign out. So in this project, we developed a smart system that can detect and prevent harmful network attacks quickly and accurately. So by focusing on the most important data and using advanced learning techniques, the system helps to keep the online services safe, reliable, and running smoothly for everyone. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.